Hello students, and welcome to this lesson on coordinate geometry. Our objective today is that we will find the slope, midpoint, and distance between 2 points using journal notes and practice problems. So the first thing that we're going to do is that we're going to remember what it means to have a slope, right? And the slope is just the rise over run between 2 points, or the change in y over the change in x. So we can write the slope as rise over run, or this is also equal to, and we're going to introduce the symbol delta, change in y over the change in x. So, given this line here, example 1, if I'm given graphically 2 points, then I can find the slope by doing the change in y over change in x. So in this case, it looks like I'm rising 3, and then I'm rising 4, and I'm running 3. So rise over run was m is equal to, I rose 4, and then I ran 3. So my slope is 4 over 3. So when we have a graph, it's too easy to do this. Now, if we don't have a graph, we can still find the slope. So if we're not given the graph, and instead we're just given 2 points, 5, 2, and our second point will be negative 10, 5, then we still have a way to do this, right? I know that m is equal to that change in y over change in x. And the way that I can describe that is y2 minus y1 over x2 minus x1. So in this case, that would be equal to, if we call this x1, y1, and x2, y2, then we'll plug it into the formula, and we'll see we have y2, or 5, minus y1, which is 2, over x2, which is negative 10, minus 5, which is x1. And so then we'll get positive 3 over negative 10 minus 5 is negative 15. And then we can reduce this. So 3 and 15 are divisible, so 15 will be divided by 3. And we can say that this is equal to negative 1 over 5. So the slope between these 2 points will be negative 1 over 5. So that's really a review from Algebra 1 and Algebra 2. We should be pretty familiar with the ability to take slopes, but now let's talk about some more geometry things. Let's talk about the midpoint. Alright, so if I have a segment here and I want to find the midpoint of this segment, then I have a formula for it. So the mid-segment is defined as the average distance, or halfway between 2 points. So the average distance, or halfway, between 2 points. And we actually have a formula for this as well. So our formula for midpoint distance is going to be x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So this actually outputs a point. So this is very different from the slope, because the slope will give us a value, right? It'll give us a numerical value. A midpoint is a point, so we actually are going to end up using it as a point. So it has an x value and a y value. Alright, so if we take our example, example 3 will be using our diagram over here to the left. So if we have these 2 points, we have negative 6, negative 6, and then we have negative 2, 0. Well, I know that my formula states that we're going to use x1 plus x2. So negative 2 plus negative 6 over 2, comma, and then I've got my y values will be negative 6 plus 0 over 2. And then we can simplify this. So negative 2 plus negative 6, that's going to be negative 8 divided by 2, comma, negative 6 divided by 2. And we can simplify this further, so we can have negative 8 divided by 2 will be negative 4, and then negative 6 divided by 2 will be negative 3. So my midpoint will end up being negative 4, negative 3. And if we look at our midpoint on here, it does indeed turn out to be 1, 2, 3, 4, negative 3. So that ends up being negative 4, negative 3 is my midpoint. Alright, and then finally let's talk about the distance formula. So we've got midpoint formula, we have our slope, which should be really familiar, and now let's talk about distance. So I want to find the distance between 2 points, or in other words, I want to find the length of the segment. Alright, so there's a special formula for this that we're going to introduce. We'll also learn about the Pythagorean theorem later, which is kind of the reason that we... So our formula for distance is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So that's our distance formula. So let's go ahead and name these points so that we can see an example. So we're going to call these points 1 and 2. And what's important here is that we see how the distance formula works and why we have these subscripts here, this x2 and x1. So when we're doing distance formula, really we're applying something called the Pythagorean theorem. And what the Pythagorean theorem does is it tells us that given a right triangle, then the length here of this hypotenuse segment, or this longest segment, is going to be equal to the square root of the squares of the legs added together. So to prove that this is true, we have this statement here. So given there exist 2 points, a right triangle can be drawn such that one leg is equal to y2 minus y1 and the other leg is equal to x2 minus x1. So we can draw a triangle then, and we have A, B, and C. And so A is equal to x2 minus x1. B is equal to y2 minus y1. And then we're trying to find C because C is that length that we were talking about earlier. So we know an equation for this is C squared is equal to A squared plus B squared. And so when we realign this, we see that C is equal to the square root of A squared plus B squared. Or we can also say that C is equal to the square root, and we replace A with x2 minus x1. And we replace B with y2 minus y1. And so there we've got our distance formula. So we replace C with D, and we have our formula. Now, I don't expect you guys to remember this proof all the time. It's something that will be new and that we're going to cover a lot this year. So just be aware that there is a relationship between distance formula and Pythagorean theorem. Alright, so I'm going to use my points from above to do example 4, so we're going to use points 1 and points 2 from our diagram. So we have point 1 here, and point 1 is at the coordinates 0, 4. And then we have point 2, and point 2 is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So point 2 is going to be at the coordinates 6, 7. And so then we can just plug these into our formulas, right? So we have D is equal to the square root of x2. It comes from the second point, and that's going to be 6. So parentheses 6 minus, and then x1 is 0 squared, plus y2 is 7, minus 4 squared. And then this is going to be equal to the square root of 6 squared plus 3 squared. So this is equal to the square root of 36 plus 9, or this is equal to the square root of, that's going to be 45. So that would be my final answer here, is the square root of 45 is the distance. So later in the course we'll learn how to kind of break this down and turn this into a simpler answer, but right now that's what I would expect, is square root of 45. Alright, so distance formula is a lot to take in. Just make sure that you're careful with your placement of your variables and your use of PEMDAS, right? Make sure that you're evaluating everything according to your order of operations. Alright, so now you can go ahead and start on your reflection. So your reflection questions are, given the points 2, negative 4, and 3, 1, you want to find the slope between those 2 points. You want to find the midpoint between those 2 points, and you want to find the distance between those 2 points. If you have any questions, please let me know. When you're done with your reflection, please ask me for a stamp and get started on your practice problems. Have a wonderful day, and I will talk to you later. Goodbye.